So we'll start with caloric intake. So the quantity of food you eat in calories determines your body mass, okay? So the weight on the scale, and it fuels performance. We'll go to the next slide. We can be in three states, essentially. We can be in a caloric deficit, a caloric surplus, or a caloric balance, okay? If I am in a caloric deficit, I am burning more calories than I'm ingesting, and if I do that long enough, I will become a smaller version of David, all right? If I'm in a caloric surplus, just the opposite, okay? I will gradually become a larger version of myself, and then if I'm in caloric balance, again, I'm gonna roughly stay around the same weight, more or less. My body composition won't change too much if I'm not playing with the macros or changing some of the variables in there. But again, I can be in one of these three states. We all exist in these three states. Most of us live around a caloric balance if we're not really paying too much attention to it. But again, these are the three states you need to be in, and you need to be in them long enough in one of these states to actually affect change if you're looking to affect change. So let's go to the next slide. So basically, this is going to be a representation of how your body uses calories, right? We ingest calories, and then what does your body do with them, okay? So this graph represents 4 different ways that your body uses calories, as well as the relative percentage that it uses those calories, okay? So the most important is our basal metabolic rate. This is just the basic underpinning to keep you alive, to keep your body temperature up, to keep your cardiovascular system working, your brain working, your gut moving, all that stuff, right? Basic, just keep you alive, is most of the calories that we consume will go to your BMR, all right? Next is going to be the thermic effect of food. So you are essentially a meat furnace, right? You ingest food, right? That food needs to be broken down inside of you, and then that food is transformed into parts of you. So I eat a piece of chicken. That chicken's broken down to amino acids. Those amino acids then become transferred to David amino acids, all right? And that's not a free process. That takes some work to actually break down and process that food and turn it into yourself. Then we have non-exercise activity thermogenesis. So this is basically what we're all doing right now. It's sitting, walking, fidgeting, even like tossing and turning while you sleep. All the basic kind of movement that you do outside of exercise, you know, walking to the subway, getting up, walking your dog, whatever it might be. So again, quite a significant portion there is neat. And then one of the smallest portions is exercise activity thermogenesis, okay? So a lot of times we think about calories in, calories out, right? And I'm saying, okay, cool, I have some level of calories that I consume, but I can really mitigate that if I exercise more. Surely that's going to be a nice counter to the food that I'm eating, right? Unfortunately, it's not the case. It's bad news for all of us, especially myself as a gym owner, all right? So I'm going to talk about something called the exercise paradox, which I think will help explain how this really works. So in 2012, Duke University did a study on the Hadza people. These are a hunter-gatherer people. And basically through urinalysis, they were able to determine how many calories these hunter-gatherers were expending on a daily basis compared to relatively sedentary office workers, right? So you have one population of people who are on the move all day, hunting, gathering, lots and lots of movement, and you have another relatively sedentary group. You would assume that surely the people who are moving a lot more, they're going to be burning more calories relative to the other group. But their findings actually were quite surprising. So for example, the Hadza women, when they compared the women, the average calories that the women in the tribe were burning were 1,877, and then in the group of the modern, sedentary workers, it was 1,864. Okay, so you're like, how could that be? And for the men, it was almost identical. All right, so you think that doesn't make sense. Like, clearly one group is more active, they're moving a lot, they must be burning and using more calories. But what the results indicated essentially is that the humans and most animals have a set point of how many calories they expend to stay alive, right? It's not good for evolution of the species if I can just kind of work myself to death, right? So how does this mechanism control? So basically, if I increase my exercise, I'm more active, what your body will likely do, the hypothesis is, it's going to decrease NEAT, it's going to decrease TEF, and it's going to decrease BMR, right? So basically, if I'm doing more, I'm burning more calories through exercise, through training, I'm going to reduce the calories I'm burning somewhere else, so that I essentially have a set point of calories that I'm burning throughout the day, regardless if I'm very active or not, okay? And we can kind of intuit, like, there's some kind of, you may experience this. So maybe like you go for a long hike, right? And then you come home and you like pass out, take a long nap. Or you spend a long day at the beach, right? Swimming and getting out with your friends, and you're like, man, I slept like a rock, right? So again, your body will auto-regulate the amount of calories you're expending to stay alive as a survival mechanism, all right? So the take-home point here is that exercise is not the most effective variable when it comes to caloric balance. Really, nutrition, how much we intake, has a far more profound impact on that caloric balance than does exercise. The old adage, you can't out-exercise a bad diet, is really true. We might see that on the assault bike when we're going for calories. And you're like, fucking 5 calories? Are you kidding me? Right? Like, I'm dying here, okay? But again, it's an important point because, I wish it could be the case that I'd say, hey, go out and eat an entire pizza, come into this Saturday class, we're gonna do a crazy chipper, and it's gonna balance itself out. It will not balance itself out. The other thing too is your body will become more efficient at exercise, right? It's like, oh, we're doing this thing. I'm gonna make my physiology even more efficient to require less energy to actually produce the exercise, the output. All right, so that is what's known as the exercise paradox.
You're gonna see a lot of people just cancel their membership.
Yeah, that's why I said this is bad news for me. Like, I wish this was the case, okay? That again, you could do that, but again, it's very important kind of principle, because a lot of people think, oh, calories in, calories out, and again, it's not two equal levers. The nutrition lever is a big, strong lever. The exercise is kind of a light switch as it relates to caloric balance. Is there anything else on that? All right, cool. Let's go to the next slide, please.